Okay, finishing up a couple examples from class today. With example 3, the first thing I would do is I would label the vertices A, B, and C. It doesn't really matter which vertex is which, but I would start with that and label the points on the graph so that when you do the 180-degree counterclockwise rotation, you'll be able to see if this makes sense. So the first thing I want you to do is label your points on the graph, and notice how I also wrote down the ordered pairs on the side. Remember that this type of transformation is going to change the ordered pairs by changing both the signs, right? We saw that xy becomes negative x, negative y. So it even helps if you write that rule down. You're going to take xy and it's going to transform to negative x, negative y. Both of them become the opposite of whatever they were. So my new a, and I want you to write these points on the side, my image of a would be negative 1, comma, negative 1, because it was 1, 1, and both of them become the opposite. My new b, my image of b, well, the x was 2, the opposite of 2 is negative 2, and the opposite of negative 2 is 2, so my image of b would be negative 2, 2. The new image of c then would be the opposite of 5, so negative 5, and the opposite of 0, but 0 doesn't really have an opposite, so it would just be 0. Let's graph this now. If I move my graph over, I can plot these points. Negative 1, 1, negative 1, negative 1 would be my new image of A. I'm going to even label that A prime. Then negative 2, 2 would be my image of B. I'll label that B prime. And then negative 5, 0 would be my image of C, and I will label that C prime. I can connect these points. Try to make a little bit of a thicker line here. I can connect these points to give my new triangle. Not very straight lines, but it'll do. Preferably we would use a ruler. And I can see that this problem, the triangle has been rotated 180 degrees. So always write the point work on the side. I definitely want to see that. So picking up from there, let's go down to example 4. The first thing I would do is I would write the starting vertices. The problem gives you the vertices, so we have negative 1, 6. We also have negative 3, 4. We have 3, 6. And we have 5, 4. We're going to take those vertices, and for problem A, I want you to construct a translation. So write this in, translation, 5 units down. So you need to write that in, which means we're going to translate this whole trapezoid, this whole quadrilateral, 5 units down on the graph. You can probably visualize where this is going to go. Each point is just going to move down 5, right? You're counting the lines, not the spaces, so it's going to move down 1, 2, 3, 4, and it would end up right there. Okay, but we know what's going to happen to the points without doing the graph. Okay, so let's go down to the points and focus on that. Remember that you're going to show me the work, so each one of these points are going to change. What changes about the ordered pair? Well, when you translate down, the y value changes. X stays the same, so we're going to keep negative 1, we're going to keep negative 3, we're going to keep 3, and we're going to keep 5. But the y values shift. Because it's going down, we will take whatever the y value was, in the first case 6, and we will subtract 5 from it. Why 5? Well, because it said we are doing a translation 5 units down. So because of that, because we want to go 5 units down, we need to take away 5 from each y value. So again, we're going to go back here. We're going to have 4. We're going to take away 5. We're going to have 6. We're going to take away 5. We're going to have 4, and we're going to take away 5. Those are the work ordered pairs. Show me where you end up. Now do those calculations. So the first ordered pair would be negative 1, 1. The second one would be negative 3, and 4 minus 5 is a negative 1. The third one would start with 3 for x. 6 minus 5 is a positive 1. And the fourth one would be 5, comma, 4 minus 5 is a negative 1. Now let's go back up and graph those 4 points. So we're going to have -1, 1. And that was actually already the first point that we graphed. -3, 1, 2, 3, -1. We're going to have 3, 1, 1, 2, 3, 1. And we're going to have 5, -1, 3, 4, 5, -1 right there. When I look at the original image and the new image, they look the same, right? They are congruent. The only thing that changed was that it shifted down 5 units, and every point moved down 5 units. We could look at that. If we count the differences here, all of these moved down 5. I do want to see the ordered pairs that go with that drawing. You don't have to draw the red arrows that I just drew, but I do have to see this ordered pair work down here, okay? Let's do the last one then. For B, I want you to do, write this in please, a reflection. I don't know why I just wrote it X. A reflection over the x-axis. So we're going to do a reflection over the x-axis here. Okay, so again, we are starting with the same ordered pairs that we did for A. Those ordered pairs are the same starting points, okay? You need to remember the rule, what happens when you reflect over the x-axis. It will help you to think about the graph, okay? Here's my x-axis. The x-axis is the horizontal line. Each of these points are going to flip over top of it. So if you think about it, this one's going to come over and land somewhere down there. This one's going to come over and land somewhere down there. I don't want you to estimate though, I want you to find it exactly. And the way we do that is we know that the x value stays the same, but the y value becomes the opposite, okay? So I'm going to erase these red arrows. We're going to actually calculate this out. But the rule, if you remember, is that x comma y would transform to x stays the same, the y value changes the opposite, okay? So here our starting points would be -1, 6, and that would become -1, -6. All you did was multiply y times the -1. All right, let's do the next one. -3, 4. We would multiply y times the -1, and we would get -3, -4. On the next one, we would have 3, 6. We would multiply the y by -1. This is another way of showing your work. You're showing me you're going to take y times the -1, and we would get 3, -6. And the last ordered pair, we would have 5, 4. We would multiply the y times the -1, and we would get 5, -4. Remember, we investigated why the y changes and the x does not. Now let's graph our new points. So we would have -1, -6, 2, 3, 4, 5, 6. We would also have -3, 1, 2, 3, -4, 1, 2, 3, 4. We would also have 3, 6, 1, 2, 3, and then down 6. And then we would also have 5, oops, sorry. We would also have 5, -4. 1, 2, 3, 4, 5, -4. When we graph our trapezoid, it should look the same size. It should be congruent to our original one, but it should look as if it's been reflected over the x-axis, over that blue line, and it has been. So hopefully this helps. We will finish the last example in class, but you should be able to do your homework.